Okay, so members, now in this lesson we are going to see how to deal with catch-up points and then meeting points. Catch-up, it means that someone is in front of you, you want to meet to reach him or her. And then meeting, someone is at opposite side of yours, then you want the two of you want to meet. Now we are going to see how do you calculate the time when the two are meeting. Please don't forget to subscribe to the channel. Okay, so this means that if two bodies are moving in, first of all, the same direction, catch-up time is going to be the relative distance, the distance between them, then over the relative speed. Relative means the difference between the two speeds. Then opposite distance, now they are at different points. Meeting time is going to be the relative distance over a total speed. Now we add here, we add their speed, here we get a difference of their speed. Their speeds. The difference between the two speeds of the two bodies is what we call the relative speed. Then the distance between the two is what we call the relative distance. So we have a question here. A car is moving at 40 kilometers per hour and a bus is 30 kilometers behind is moving at 60 kilometers in the same direction. So they are in the same direction. At the time when the bus catch up with the car. So it means that now from here up here is going to be 30 kilometers. The distance between the two, between the car and then the bus. Now, we assume that this is their meeting point, and we assume that time is going to be t when all of them are meeting. It means that now, the time t is going to be the relative distance speed. So now our time here is going to be the distance between the two is 30 over the distance, the difference between the two speeds. So 60 then minus 40, which will be 30 over 20, and this is going to be 1.5 hours. Now they are asking that, so that's the time when they will meet. From their point where they are going to take 1.5 to reach that time t. Then this is part A. Then part B, the distance moved by the bus at the time at this point. So from here up to here, the bus is going to use this time t, but it's moving at 60 kilometers per hour. So now that distance, part B, the distance is going to be now speed times time. The speed this bus is moving at is 60, then the time that it requires it to reach this point is going to be 1.5, and when you cut it there, I think it's going to be, this is 3 over 2, 90 kilometers. 90 kilometers. So that's the distance. Alternatively, some people like this. Alternatively, if you have these two things here, this is our meeting point. We have the time there at dt. So this is going to be our car, and this is going to be our bus. 60 kilometers per hour. Then this one is moving at 40 kilometers per hour. It means that now, if the time for them to be here is going to be t, it means that this one is going to move this distance 40, then time is t to cover this distance. Then this bus, remember the distance between these two, from here up to here, is 30 kilometers. Now for the bus to move from here up to here, for it it's going to use the speed at which it's moving, then times the time when it reaches that point. And there is that. Now this 60t is going to be now 30, then plus this distance which is 40t. And then take this side. We have 20t equaling that our t is going to be 3 over 2, which is 1.5 hours. Then the bus that is going to be the distance now, the same idea. Or you consider this is going to be 30 now plus 40t, which will be 30 now plus 40 times 1.5, which is going to be 30 plus over here you get 60, which is going to be 90 kilometers. Or you get 60 times t. which is already here, and you've seen it's already giving us 90 degrees. So that's how you can hand that to members. We are going to now when they are moving in opposite directions. I wish you the best.